Welcome! Today we're going to dive deep into the multi-point alignment capability of the Alpaca version 2.0 driver. Now, to enable this capability, you can go into settings, and in the advanced control features there's a checkbox here, and to turn it on all you need to do is click that, and that will enable multi-point alignment. If you have it disabled, all that means is it's going to use the single star alignment that's in the Polaris firmware, pretty much how it used to work with version 1.0. You can still plate solve and do everything the same, it's still perfectly fine. If you enable multi-point alignment, it brings in extra degree of precision around the alignment. Now we also have a new alignment page, which also allows you to toggle between single or multi-point alignment. Okay, before we actually do a multi-point alignment, I just want to do a quick recap on Nina and how to do plate solves in there. So if you go into the options tab of Nina, then go to the equipment, just make sure that you've got the pixel size of your camera set correctly for the sensor that you're using, and also make sure that the focal length is set to the correct focal length of your telescope or lens that you've got on your camera. The other thing to check is under options, under plate solve, make sure you've got ASTAP selected as the solver and the blind solver, and that you've set the ASTAP executable location in the plate solver settings. You want to have a short exposure time, so I recommend having either 1 second or 2 second exposure. And to initiate a plate solve, do it manually from the imaging tab. If you've got live view running, which I do at the moment, you need to turn that off. And there's a tool here called plate solving. Click that, you'll get a new panel, the plate solving panel. And what you want to make sure here is that you've got sync enabled. So this causes the plate solve to send its result down to the Alpaca driver and into the multi-point alignment model. Once you've got the telescope oriented the direction you want to do a plate solve, you just come along here and press this play button and it'll initiate a manual plate solve. Okay, coming back to the pilot application. To do a multi-point alignment, you need to plate solve for 2 or more points spaced around the sky. Now ideally one of those points is going to be at your local celestial pole, so I'll actually do that now. You can just type in pole into the search, it'll come up with the north and south celestial pole. Just pick the one that's near you and we'll go to that. Across to the south pole here in the southern hemisphere, and you want to let that complete the go-to. Once it's in position, I would go back to Nina and I'd initiate a plate solve there. I'm just going to simulate that because it's actually during the day. And when you do that, if you have a look on the alignment page, you'll see the first sinkers come through. It's at close to 180 degrees azimuth, south pole, and it's at my latitude. I always get them confused anyway. Now the second point that you probably want to choose is probably going to be around the trajectory of your target. Now tonight I'm going to be targeting the Cadwell 106. I'm going to go to that, which is a nice globular cluster near the small Magellan cloud. In fact, you can see it here. It's just zooming in on it. Now, ideally you want a few points around where this target is going to progress as you're doing your imaging, so that you've got it nicely aligned here and where it is at the moment. We've added a feature to allow you to easily do that. If you switch to the equatorial mode, so what you can do is you can do a relative set point change, and to do a relative change you put in D for delta, and I can just put in -2 and enter, and what that will do is it will move the telescope 2 hours into the future of where that target will be. And once that's settled, I will do another plate solve. So we go back to Nina and initiate another plate solve, And then for the final one, you want to go to the target that you've actually been looking for. Let's go back to Cadwell 106, back to present time. And once it's settled there, and do your final plate solve. So we've done 3 plate solves. In this panel here, you can see the telescope alignment model, and it lists all of the sync points that we've actually performed. We did one at the South Celestial Pole at 180.33.6. We did one 2 hours into the future where our target will be, and the last one we did was where the current target of Took 47 is. So based on these 3 sync points and the plate solves of each of those, it's worked out a model, a correction model, and it's summarised it in these 3 numbers here. It's saying that it's actually twisting the azimuth axis by minus 16.2 arc minutes, which is not much, but it's making a minor correction there. And it's also correcting a slight tilt in my tripod of 1.5, sorry, I said arc minutes, I meant arc seconds, 1.5 arc seconds, which is very small. And it's saying that the highest point on my tripod was actually sort of in the southwest. Once it's got its model, it tries to fit all of these sync points into that model. And where there's a slight deviation between what that sync point said it was and what the model thinks it should have been, it'll list it as a residual. The last one will always be 0, but the other sync points that are in this list, they might be larger. If you see anything above, say, 5 degrees, then you might want to consider deleting that point, and you can delete it by just clicking on the cross here. If you see it above 10 or 20, then I'd definitely remove that point from the multi-point alignment model. You really want to keep them down in the arc minutes, and these are arc seconds. So this is a very good alignment that we've got here. So there we go. So I've now got a 3-point alignment model, and I can set up a sequence and start imaging, and I should get better tracking that I'll get than from a single star align. So what we'll do next is we'll talk about, if you don't have plate solving available, there are other ways that you can actually add sync points into the model. We're going to use visual confirmation of where the telescope is pointing, and we're going to initially do that with celestial objects. So what you can do is, after you've done a go-to, say to the target that you're after, you can see that it's not quite aligned. So what I want to do is to align it precisely. So if you've got the ability to zoom in with your camera, that's a good idea. You can use these radial dials to tune in and get it accurately with it. I need to decrease the right ascension. I need to 19-minute scale and start decreasing it. That should move it at a good pace that we can control. Okay, I'll just bring it back a bit. And notice that I'm really only adjusting the set point here, and then it settles on where I had it. So it's very easy to just finely tune it, and that looks pretty accurate there now. So I can go back to the target and I can hit this sync button. It's basically saying this particular target is dead center of the image, and I'm going to sync it, and it'll add it as another point in the model. You can do that also in Stellarium. If you've got the ASCOM interface for Stellarium, I can then say current object and then sync, and that will also be another way you can add a sync point. So you can do it from Stellarium, and you can do it from the pilot application. Okay, so that's the second way you can add sync points to the model. The first way was with plate solves. The second way is with celestial targets with right ascension and declination. And the third way is now with the pilot application, you can actually do it with azimuth and altitude points as well. So in my case here, at my location, I actually use a high tension power line that is quite easily visible from my backyard. and zoom in on where the high tension power line is. It's right here, and if I click right on it, it will actually draw a line between my observing site location and that location of the landmark that I can see in my camera and have it pointing directly at it, and it works out what the azimuth is, altitude in degrees relative to this location is, and then I can press sync. A good example because it shows what happens when you put in an incorrect sync, and it's mucked up my whole model here. It's showing that if I make this last point is actually true, then all these other points are really wacky. So this is indicating that there's a real problem with my model, and it would suggest if this was correct, you really want to delete each of these other points. But we know that I was just making that up in this case, so we want to delete that last point. It will recalculate it and correct the model back to what it was. So that's the third approach that you can take. Again, you can also manually enter in if you know where you are. If you've got your camera and it's really wacky and it's pointing in the wrong direction and there's some bad sync in there, you can just delete all of those, come to this multi-point alignment, come to the geographic, and you say, I know it's going to be pointing at 180 degrees azimuth, at 45 degrees in altitude, and I can do a sync there, and that will correct your model so that you're correctly pointing. Okay, the last thing I wanted to show you is how the multi-point alignment model can correct tripod tilt. Now, as you can see here with my block of wood, I've got a serious tripod tilt problem. It's a bit wonky. So what we're going to try and do is I'm going to manually enter in some sync points to try and get this thing aligned correctly. So the first thing I want to probably do is let's just move this to point towards the north, just so we know where we're going. And I'm going to estimate that this angle here is about 15 degrees off. So come in here and I want to manually enter in a coordinate. Now I know it's north, so the azimuth is 0, 60 degrees, and I'm going to perform a sync. Okay, now you can see I've added that point to the model, and it's saying it's correcting for a tilt angle of 15 degrees. And the highest point on that tilt is at an azimuth of a couple of arc seconds. So it's exactly what I'd think, because the highest point on this tilt is to the north. So if I come back to the dashboard now, you can see that it's pointing north and it's got an angle of 60 degrees. If I want to see if I can bring it down to level, let's see if I can do that. Bring that down to 45. Let's see what it looks like. That looks pretty reasonable. So let's take this to the opposite direction. So it goes that way. That still looks a bit wonky, doesn't it? Let's see if we can do this. I'm going to give it another point because it needs more than one. Although it's not doing too bad. At this point here, I expect it to be 180.45, so I'm going to go to the alignment page and I'm going to manually enter that in. 180.45, click sync. Now the real test will be if I can move this to, say, let's bring it down to an angle that's nearly horizontal, pointing south. In fact, let's go fully horizontal. That looks pretty good. And I want to bring it to point west, which is directly towards us. Oh, what? It's not too bad. And it's keeping it level. So I think that's doing a pretty good job. It's pointing directly to us and it's keeping it level. So if I wanted to, say, take it up to 30 degrees, but staying pointing at us, there we go. It's pointing west, and it's at an altitude of 30 degrees. So you can see this simple model, I've really only got two sync points in this model, but it's making a 15-degree tilt correction in the tripod. So when you do plate solves, it'll actually work out how your tripod's tilted and take that correction and counteract it so that your azimuth and altitude and roll are more accurately representing what it is, and the same with the equatorial coordinates so that your tracking is better. So the next challenge I've got is to put a wedge in the tripod, and I'm going to try and align one of the axes with the celestial pole and see if we can get the axis of the Benro Polaris aligned with the Earth's rotation axis and turn this into a true equatorial mount like the Sea Star does. That's really all I've got today. I hope you enjoyed the deep dive into multi-point alignment, and I hope it improves your tracking and accuracy of capturing images over the night. Bye for now.